Okay, we're going to try 4.8 again. Um, Only because the first time I recorded it, it was confusing and there's a lot of stuff going on, so I've rewritten a large portion of the notes. So bear with me. 4.8 is all about solving linear and quadratic inequalities. The steps aren't too bad for solving them. You're basically going to rearrange into slope-intercept form. If you recall, that was y equals mx plus b. But because it is an inequality, it doesn't equal 0, or it doesn't equal y, so it's really just mx plus b. We're going to find our zeros and our y-intercepts for inequalities. For a linear, a straight line, you're just going to basically graph using your y-intercept, which is b. Once you've graphed b, you're going to take that point and then graph out your slope, which is m. You're going to join those two with a line, and then we're going to basically create our inequality based off of this graph. So, if we have the inequality, 3x plus 1 is greater than negative 5. To graph this, we need to basically take everything and put it on one side. So we're going to take our negative 5, we're going to add 5 to both sides. What I'm going to get is 3x plus 6 is greater than 0. No, my y-intercept is going to be at 6. So I'm going to go from y-axis and go plus 6. My slope is 3. Technically, it's 3 over 1. So I'm going to go up 3, 1, 2, 3, and over 1. Or I can go down negative 3 and to the left negative 1. It's the same slope. What matters for us is we notice that we cross the y-axis at negative 2 and 0. So when I draw my line, I go 0, negative 1, negative 2, negative 3, fill it in properly. So, what I need to know here is my inequality, I can do one of two things. I can look at my graph and pick a point for x that is both in front and behind negative 2 to see which way my arrow is going to go. I know my arrow is hollow because there's no line underneath my inequality. I'm going to pick the point 0 and 0. I'm going to pick the point at a little bit extreme here, which is going to be negative 10, and I don't know my y value. Doesn't really matter. So when I go 3x, plug in negative 10, plus 6 is greater than 0, I then solve to see if this is a true statement. 3 times negative 10 is negative 30, plus 6 is only negative 24. That is not greater than 0, so I know that my arrow could not go left, it must go right. And if I wanted to test this just to make sure, I could plug in 0. So 3 times 0 plus 6 is greater than 0. 3 times 0 is 0, 6 is greater than 0, so it does work. I know my arrow then goes off into the right direction. It was going to be much more complicated than that, but that's kind of the easy two ways. Just test 2 points and go from there. As far as steps for solving the quadratic, okay, we're going to move all terms to one side of the equation. Using your preferred method for solving, we are then going to find your two zeros, and using the graph, we're then going to create our number line. So, I'm going to use the example y, negative x squared minus 3x is less than or equal to x. I'm going to get all my x's on one side, so I'm going to subtract x from both sides. So I'm left with negative x squared minus 4x is less than or equal to 0. I'm going to use the quadratic function just because I think it'll be a bit easier in this situation. If you guys remember, we have to find ax squared plus bx plus c, because the quadratic function is negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. The thing to note here is we don't actually have a c value. So wherever you see a c, we're going to put in 0. So b is negative 4, so we have a negative 4 plus or minus the square root of negative 4 squared minus 4 times a, which is negative 1, times 0. And this whole thing is divided by 2 times negative 1. Negative 4 turns into positive 4 plus or minus the square root of negative 4 squared is 16. Negative 4 times 1 is positive 4, and 4 times 0 is simply 0. This will be divided by negative 2. The square root of 16 we know is 4. So really our two zeros are 4 plus or minus 4 divided by 2, or negative 2. So 4 minus 4 turns into 0 divided by 2, which equals 0 as one of our x-axes, or one of where we cross the x-axis. And 4 plus 4 is 8, and 8 divided by 2, or 8 divided by negative 2, turns into negative 4. So I know the 2 points on my graph are going to be at 0 and negative 4. And we would fill these in. So 0 and negative 4. Because it's just a negative a out front, we know this guy is going down. And a quick review from yesterday, we want to find the average between negative 4 and 0. Negative 4 plus 0 divided by 2, so we know it's at negative 2 is our axis of symmetry. And to find out my upper limit, I'm going to plug in negative 2 for x and solve for y. So y would equal negative x squared minus 4x. So minus negative 2 squared minus 4 times negative 2. So negative 2 squared would be 4. So I have negative 4, and negative 4 times negative 2 turns into positive 8. Negative 4 plus 8, so I know that y is going to be positive 4 when x equals negative 2. So negative 2, 1, 2, 3, 4. So my parabola is going to look like that. To put this on a number line, zero, 1, 2. I have my 2 points, which is going to be 0, filled in, and negative 4. Fill that in as well. I'm now more or less going to pick 3 points to plug into my original inequality and see if I have a true statement, because I want to see which way my arrows are going. So I'm going to pick negative 5, negative 2, and positive 2. So we'll start with negative 5. So minus negative 5 squared minus, actually, we couldn't use either of these, up to you. I might actually use this guy. Be a little bit easier for us. Minus 4 times negative 5 is greater than or equal to 0. Negative 5 squared is 25, so we're going to have negative 25. Negative 4 times negative 5 is plus 20. Is greater than or equal to 0. So, is negative 5 greater than or equal to 0? No, it is not. So we know that our arrow does not go to the left. If I use negative 1, negative 1 squared minus 4 times negative 1 is less than or greater than or equal to 0. So negative 1 squared is 1, so we're going to have negative 1, negative 4 times negative 1 is positive 4. Negative 1 plus 4 is 3, which is greater than or equal to 0. It absolutely is. So we know that our first line goes off to the right. Looking at our last point here, we're going to pick 2. I've run out of room, so I'm going to use the bottom. So we're going to have negative 2 squared minus 4 times 2 is greater than or equal to 0. 2 squared is 4, so we have negative 4 minus 4 times 2 is 8. Is greater than or equal to 0 is negative 12. No, it is not. So we know that our two lines kind of have to just connect over there. Neither of them go off to the right. If we look at this, another method, without using the quadratic function, but we just wanted to put, we'll say, x squared plus 7x plus 10 on a line. Got a few options. You can just factor it normally, right? Two things that multiply to 10 add up to 2. We're going to have x plus 5 and x plus 2. Normally we would set these equal to 0, but because it's an inequality, we're going to have them set equal to we'll have them greater than or equal to 0, and x plus 2 greater than or equal to 0. You solve it normally, take 5 other side. And these are essentially your two zeros for your quadratic function. You could graph it, we don't really have to, because we're going to do the exact same thing we did last time, is we're going to draw a number line. We're going to make sure there's negative 2. Again, these are filled in because they're less than or equal to. Now you can just look at the symbols and say, well, I understand where this is going. X has to be larger than negative 5. So, and x has to be greater than or equal to negative 2. But we should always test that just to make sure. And again, we're going to pick the same thing. Two middle points. So we have negative 6, negative 3, and 0. We'll punch that into our original equation. Negative 6 squared plus 7 times 6 plus 10 is greater than or equal to 0. Negative 6 squared is going to be 36 plus 7 times 6, which is 42, plus 10 is a very large number, so it's going to be, what's that, 88? And 88 is indeed greater than or equal to 0. For question, or for negative 3, we'll have negative 3 squared plus 7 times negative 3 plus 10 is greater than or equal to 0. So we're going to have 9, we'll have negative 21, and we'll have 10. 19 minus 21 should be negative 2, and negative 2 is not greater than or equal to 0. So again, we know we're going to right, wouldn't be in the center. Our last step, 0 squared plus 7 times 0 plus 10 is greater than or equal to 0. 0 squared is 0, 7 times 0 is 0. Is 10 greater than or equal to 0? Absolutely. So we can fill in our graph like so. Okay. The homework for this guy is just 2 questions. I want you to graph or put on the number line the following: x squared minus x minus 6 is less than 0, and 2x squared minus 9x minus 5 is less than or equal to 0. Please put both these on a number line. The last thing is your text, page 355, questions 3, 4, and 9 would be what I would normally assign. Only do this if you're in pre-cal 11 when to go into Pre-Cal 12, or if you need extra work. The only two things that we marked will be these two questions. If you have any questions or concerns, feel free to ask me them on Tuesday and Thursday. Otherwise, good luck.